In this video, we're going to be looking at similar triangles. If one shape is an enlargement of another, we say they are mathematically similar. This means that there is a common scale factor of enlargement between corresponding sides of each shape. So if we've got two triangles here, a small one and a big one, if you look at the corresponding sides and they've been coloured accordingly, you can see that in the big triangle, the sides are 3 times bigger than the small triangle. The small triangle has been enlarged by a scale factor of 3. These triangles are mathematically similar. If we have two similar triangles, we're able to perform some calculations to be able to find missing lengths. We know these triangles are similar because all the angles in each triangle are the same, and we can see that by the markings of 1 and 2 arcs in the corners and a blank one. Now the first thing we do is identify corresponding sides. And you see those sides I just pointed to there. They're in the same place. They're both between a blank angle and a single angle. So I'm going to shade them red. Now I'm going to go from a 1 and a 2. I'm going to colour those ones in yellow. They are corresponding sides. Now the important lengths here are the red ones because they're known in both of the triangles. So we're going to set this up. To find x, we're going to do x divided by 8. And that's going to be the same as 3.5, which is in the corresponding place on the yellow line, divided by 2, which is in the corresponding place in the other triangle. Now, to find what x is going to be, we simply multiply both sides by 8, and we work it out on the calculator, and we get 14 as the answer. Let's look at the same thing. We want to find y. So we do y divided by 2, and that's equal to, well, the corresponding place to y is the 12, and the corresponding one to 2 is the 8. So y is 12 over 8 times 2, and we multiply that out, and we get an answer of 3. So the denominators are both the 2 and the 8. Same as before. This is a similar triangle because the angles are the same. So we need to first of all identify the sides are the same. So look between the angles. So I'm going between the 1 and the 2 angles this time. I'm going to do that one green. And then I'm going to go from the 1 and a no angle. So I'm going to call that one red. Now we want to find x. So we need to identify which are the corresponding sides that we know. Well, it's the green ones. So I'm going to do x divided by 8 is going to equal to 18 divided by 24. So, same as before, we're going to multiply both sides by 8, and we're going to work out our answer, get an answer of 6. Now to find y divided by 24 is equal to, well, the corresponding side to the y is the one without a colour, so that's 7.5. Divided by 8, multiplying both sides by 24, and we can just do that on a calculator, or we can work it out on our head if we need to. We get 22.5. And similarly with our third example, again, they're similar because the angles are all the same. Let's identify the corresponding sign. So I'm going between the 1 and the 2 angle. Let's shade that one in green. And then I'm going to go between the 2 and the blank. So I'm going to make that one red. This time it's the grey one, which is the same in both. It's the 10 and the 12. So they're going to be our denominators. I want to find x, so I'm going to say x over 12 is equal to, well, the corresponding one to x is the 14, is the green one. So it's 14 over 10. Multiply both sides by 12. I'm working it out on a calculator, and we get 16.8. Similarly for y, so y divided by 10 is equal to, well, the corresponding sign to y is 13.2 divided by 12. I'm working that one out, and we get our answer of 11.